Hello friends, welcome to Electronic Circuit Hub. So in the series of high-speed design tricks, today we are going to understand about the crosstalk. So this is the sixth video of high-speed design tricks. Okay, so this is going to be very interesting topic today. So we will understand what is the crosstalk, right? What is the causes of crosstalk and how to reduce the crosstalk in the PCB. Okay, so we will also understand the various terminology like what is mutual capacitance in the PCB and what is the mutual inductance in the PCB. So let us first understand the basics. What is crosstalk, right? So, so the crosstalk is a unwanted interference caused by energy coupling from one PCB track to another PCB track due to electric and magnetic field coupling. Okay. So as you can see here, there is a PCB which is routed here. You can see there is a track. So what is the crosstalk? If you want to understand more in detail in the PCB, so you can see any two track which can cause the crosstalk if they are not properly designed and they do not have a proper termination. Okay. So basically crosstalk is a energy coupling from one PCB track to another PCB track in the terms of electric field and the magnetic field. Okay, let us understand what happens due to electric field and let us understand what happens due to magnetic field. Right. So, if you want to go more in details about electric field generates mutual capacitance between two PCB traces and mutual capacitance passes the current in both directions to the victim. Okay. So due to electric field, mutual capacitance gets generated and it passes the current in the both direction to the victim PCB or victim track, right? And what is magnetic field? So magnetic field generate mutual inductance between two PCB traces and due to mutual inductance, it generates induced current in the adjacent track which is opposite in the polarity, right? So let us understand more in detail what is mutual capacitance and what is mutual inductance. Okay, so in this slide you can see when the two traces are parallel to each other and they are separated by a dielectric, and if they are at two different voltages, an electric field generated between them. Any variation in voltage in one trace will induce electric current. So you can see by this diagram, let us assume these two are the parallel traces. One is this one and one is this one. And you can see this is the source impedance ZS and this is the output impedance Z0, and you can see there is a near field and there is a far field. So what is mutual capacitance? Traces are if two traces if two parallel traces are separated by some dielectric or some distance. So you can see this is one trace, this is trace number 2, and they are separated by a some distance. So this causes a to generate electric field, and due to that it generates the voltage, and any variation in the voltage in one trace will induce electric current in another trace. So this is basically a mutual capacitance. What is mutual inductance? When a current carrying traces has a magnetic field around it, and if there is a second trace close to first trace, the magnetic field coupled to the second trace, according to Faraday's law, any changes in current in the first trace will induce a voltage in the second trace. So let us assume this is the first trace and this is the second trace. And according to Faraday's law, if any changes in the if any change in the current in the first trace, that will induce a induced voltage in the second trace, and you can see this is done by the mutual inductance Lm. Here you can see the mutual inductance is Lm, and here you can see the mutual capacitance is Cm, denoted by Cm, and inductance is denoted by L1. So if you want to calculate the near field current, that is equal to common mode current uh, plus magnetic current. Okay, current induced due to mutual inductance, and far end current is equal to ICM, that is common mode current minus current induced by mutual inductance. So hope you understand what is the role of electric field and magnetic field, what is mutual capacitance, and what is mutual inductance, right? So let us move ahead. What is the causes for crosstalk? Capacitive coupling can causes for crosstalk. Inductive coupling is a reason for the crosstalk. Difference in propagation velocity also can cause the crosstalk. PCB vias can also induce crosstalk, and if you have a higher data rates, that can also induce the crosstalk. Okay, crosstalk in differential pair signal. Let us This is for differential pair signal. So common mode crosstalk, differential mode crosstalk, and mixed mode crosstalk. These are the various type of crosstalk which can induced in differential mode signal, right? So now the next question is how the technique to reduce the crosstalk. That means how will you reduce the crosstalk? So the first technique is increase the spacing between two signal lines. Follow the differential routing techniques. Avoid long trace routing. Use of ground guard trace. Use of God ground trace. Don't decrease signal rise time, and use a T termination. This is, you can see, this is T termination, right? So the last topic is how crosstalk can be measured. So crosstalk in dB is given by 20 log voltage victim divided by voltage aggressor. The higher the value of dB, the lesser crosstalk, right? Make sure that crosstalk should not increase above 150 millivolt. So hope you today you have understand about what is crosstalk, what is the causes of crosstalk, and how to overcome the crosstalk. What is electric field? What is magnetic field? What is mutual inductance? What is mutual capacitance? Okay. If you have any question, feel free to ask me in comment section. Thanks for watching this video.